Welcome back again. Welcome to Technical Mathematics, where we are tackling the area under the curve questions. So the one that we have right now in front of us, it says that the sketch below, it represents the shaded area bounded by the curve of the function which is defined by f of x. So the function that we have right here is given by f of x, it is equals to 3 divided by x minus 4, where they say x must be greater than 0 and the x is between the points. We have x equals to 2 and x equals to 4, so these 2 points represents the boundaries. So this is the area that is shaded. They say show all calculations the shaded area bounded by the curve and the axis between the points x equals to 2 and x equals to 4. So this is the function we are going to be working with, that we are going to integrate. So first, let's try and find the area under this curve. So the function that we have, it is 3 divided by x minus 4. We are integrating this between the lower and the upper one. So the lower one is 2 and the upper one is 4. Not forgetting to write dx there. So what am I going to do here is to separate this integration, just for a better understanding. So in other words, 3 divided by x dx, you are integrating this between 2 and 4, and then you have minus, and then you integrate 4 dx, you are integrating this between 2 and 4. You can integrate this all at once, it's still okay, but this method, it makes it much more easier because of you're only integrating this part alone, and you're only integrating this part alone, and then you get to do your substitution accordingly. So now 3 divided by x, we know that it is rule number 2. Rule number 2, let's remind ourselves of rule number 2. Rule number 2, it says that if you're integrating a divided by x dx, this is the same as a into the ln of x plus c. So we're going to apply this rule here. So when we're going to integrate, this is going to be 3 into the ln of x, and then you write down the boundaries of integration between 2 and 4, minus, this is a constant, the integral of 4 is going to be 4x, the boundaries of integration, it is between 2 and 4. And then you do your substitution. So you're going to have 3 into the ln of, you start first with 4, minus 3 into the ln of, and then you substitute 2. Let me put this into my brackets like this, and then minus, you open bracket, you have 4 into 4 minus 4 into 2. Great, ne? So let's get a calculator. So what we are going to do, we're going to substitute this part here. Where you find your ln, it's there on your calculator. So we're going to have 3 into the ln of 4, and then you minus 3 into the ln of 2. Put that in a calculator like that, close the bracket, you press equals to, we get 2,07. So here I'm going to write this as 2,07 minus, and then you do this one. You can also, let's bring back that calculator, 2,079. Okay, no problem. This one is gonna be 4 into 4, 4 into 4 minus, let's delete that, minus 4 into what? 4 into 2. This one is going to give us 8. So the answer that we get here, it is 8. So we're going to get a negative value, and I'll just explain in a while why do we get a negative value. 2,079, let's just include that, minus 8 is going to give us negative 5,92. Negative 5,92. Okay, let's negative 5,92. since this one is a area unit squared, allow me to write the statement here below the x-axis. Now why? Somebody can ask, why is the area negative? The area is not really negative. The negative sign here, it just represents where is the area allocated. When you look at it on the graph, the area, it is located below the x-axis. So if it is below the x-axis, the area, it is expected to be negative. If the area, maybe say it was above the x-axis, then it was expected, you should rather expect it to be positive, but in this case it's going to be negative because of it is located below the x-axis. But that doesn't change the magnitude. The negative sign here just represents the direction of your area. It is below the x-axis, so you should just write the conclusion, just say 5,92 units, and then you just can just write that. Or this is the area below the x, this is the area below the x-axis, and that, my friends, is how you go about simplifying that question. Let's catch you on the next one.